Welcome to this lecture dedicated to mining. I would like to thank Anders Brownworth for setting up an excellent website which makes it very clear what a block is and what mining means. So let's go on the block page. So a block is very simple. It's the number of the block first, then a number called the nounce, which means nonsense, that we are trying to guess in mining. The data field contains the transaction you decide to mine. So let's say you include just one transaction. A gives 2 bitcoins to B. The hash is the hash of the number of the block, the nonce, and the data field. So it's a fixed length string. So what mining means is finding a nonce such as the hash will start with a 0. So by mining, we'll just try all the number from 0 to infinity till the hash starts with a 0. Let's try 0. Okay, you see that the hash starts with a B. Let's try 1 now. It starts with an 8. Let's start 2. It starts with a 7. I am actually mining this block. 3, no. 4, no. 5, no. 6, no. I'm mining the block. 7, no. 8. So you see, this is a process that takes time. Look, 9 is a solution. So I mine this block, and the solution is the nonce equaling 9. So actually, we're not going to look for 1 0, but the hash to start with 4 zeros. I'm not going to do it manually. There is a button called Mine that Anders Brownworth designed to automatically try all the numbers from 0 to infinity. So let's press this number. You see, and it was pretty fast, the solution, a solution is 1016, for which the hash starts with 4 zeros. For a real blockchain, I mean a blockchain which is a chain of blocks, actually, a block contains the hash of the previous block also. So let's make it clear about a block within a blockchain. There is the number of the block, let's say number 2. There is the nonce, this number to be found by mining. The data field, that is the transaction you decide to mine. So A gives, let's say, 5 bitcoins to B, transactions you pick in the network, transactions that occurred between peers of the Bitcoin community. You see, here there is the hash of the previous block, okay, here. And now the hash field will be the hash of the block, nonce, data, and previous block, okay? So just a little bit different. So same here. If you want to mine this block, you press this button. And here it is. The solution was found pretty quickly. It's 9,586, for which the hash of the block starts with 4 zeros. So you see, it takes time. So now let's go on the Explorer to see the hash of a block mined, let's say, an hour ago. Okay, let's check this block. This block is the block 632,569. And you see the hash starts not with 4 zeros, but with like 18 zeros. So it's much more complicated and it takes much more time. And you can see here that the nonce to be found was 1,690,000,000, etc. Okay? So this is the nonce to be found to win the competition. And you can check that for early blocks, like let's say block 1000, okay? Block 1000, what happens is you look at the hash, the number of zeros required was only 1, 2, 3, 4, 5, 6, 7, 8 zeros and not 18. It was much easier at the time. So the difficulty of the problem augments with time to go with the fact that the computer becomes more and more powerful. So let's say tomorrow the hashing power of the computer doubles. Then the number of zero required will raise so the problem takes always 10 minutes to solve. Remember, by design in Bitcoin blockchain, the mining problem has to take 10 minutes to be solved. And this assures the immutability of the blockchain. So we'll see how. We come back to Anders Brownworth blockchain, and we are mining this blockchain by, we're doing a block. A gives 2 Bitcoins to B. So to B, yeah. So I've just modified block 2, okay? Of course, it's not anymore valid. You see, the hash doesn't start with 4 zeros. But what happens is the next block, block number 3, because it contains the hash of block number 2 in the previous field, is not valid anymore. Look, it starts with D, so it's not valid anymore. Same for block 4 and block 5. So it means that the simple fact of modifying something in block 2 invalidate block 2, of course, but also block 3, block 4, and block 5. And if you want to make this chain valid to the Bitcoin network, you need to mine block 2. It takes time to find the appropriate hash. It takes time. It actually takes at least 10 minutes by design. You need to mine the next block. It will take 10 minutes again. The next block, it will take 10 minutes again. The next block, 10 minutes again. So you see how much time it will take you if you modify a single transaction in the blockchain to make it a valid blockchain again. And during this time, a miner will have mined block 6, block 7, block 8, okay? So you will be okay with a 5-block chain, which is valid, but you're not ahead of the game because there's somebody having a blockchain with 6, 7, 8 blocks. So it makes it impossible to modify. At least it worked so far. So that is the principle of mining and how it makes a blockchain immutable. So well done. I strongly recommend you manipulate this website so you really see what mining means. Congratulations, you understood what mining means. Now, I'll end this lecture by a fun thing. It's a website called bitcoinstrings.com. You'll find it in the link. And on this website, this developer, this guy, played a game is to write what's written in the 40 left bytes of a transaction line. Because actually in the Bitcoin blockchain, every line is a transaction. So you got the transaction, A gives 2 Bitcoins to B. At the end, there are 40 bytes left, unused bytes. And it's possible to write something in this 40 left bytes. So let's see what's in block 0. So in block 0, you see it's written for the first transaction. At the end of it, it's written the times 3rd of January 2009, Chancellor on brink of second bailout for banks. And a funny fact, if you go to block 3, you see that I remind you, each line corresponds to a transaction. For block 3, you got drawings, you got poetry, all kind of things. And look what you can see here. You can see the portrait of Ben Bernanke, the boss of the Federal Reserve, the ex-boss of the Federal Reserve. So that can be funny to browse what's written or drawn into the blocks. So in the next lecture now, we'll see who are the miners. I'll see you in the next lecture.